sleep on it. Just like hunger, thirst, and sexual desire, the urge to sleep is a physiological drive. But exactly what spending a third of our lives unconscious gets us has long mystified scientists. Alan Rechtschaffen, one of the world's foremost sleep researchers, said in 1978, "If sleep does not serve an absolutely vital function, then it is the biggest mistake the evolutionary process has ever made." In the 1990s, J. Allen Hobson, another leading sleep researcher, quipped that the only known function of sleep was to cure sleepiness. Research over the past 20 years suggests sleep doesn't serve just a single purpose. Instead, it appears to optimize a multitude of biological processes, from the immune system and hormonal balance, to emotional and psychiatric health, to learning and memory. Yet sleep seems to enhance the performance of these systems, rather than being absolutely necessary. Still, anyone who goes for months without sleep will die. The clearest evidence of our absolute need for sleep comes from a study published in 1989 by Carol Everson, based on work she did while at Rechtschaffen's laboratory at the University of Chicago. She found that rats totally deprived of sleep all died within a month. Actually, all she had to do to achieve this fatal result was to prevent the animals from entering the stage of sleep characterized by rapid eye movement, REM. But a quarter of a century later, researchers still can't explain why the rats died. A series of experiments in the intervening years has only served to eliminate possible causes. For example, it isn't caused by increased stress, excessive energy consumption, or failure of the body's internal heat regulators, or the immune system. Still, we do know that as little as one night of even partial sleep loss can interfere with various bodily functions, such as protection against infections and hormonal activity. 2 studies looking at the body's response to immunization with hepatitis vaccines shows how dramatic the effects of sleep deprivation can be on the immune system. In the first experiment from 2003, a small group of college students received a standard hepatitis A vaccination in the morning. Half of them were permitted to sleep normally. The other half were kept awake until the following night. 4 weeks later, researchers found that the group who'd gotten a normal night's sleep had 97% higher protective antibody levels than the sleep-deprived group. In the second study, adults received the standard 3 doses of hepatitis B vaccine over the course of 6 months. By comparing the subjects' average amount of sleep during the week of their first shot to the level of antibody protection they displayed after the second shot, investigators determined that antibody levels increased 56% for each additional hour of sleep. 6 months after the final vaccination, those who'd averaged less than 6 hours of sleep a night during the week around the first vaccination were 7 times likelier to have such low amounts of antibodies in their blood that they were considered unprotected against hepatitis B. As for hormonal function, in one of their experiments, Corrine Spiegel and Eve Van Cauter of the University of Chicago allowed 11 healthy young men to get just 4 hours of sleep a night. After 5 nights of restricted sleep, the men's ability to clear glucose from their blood, a process managed by the hormone insulin, was reduced by 40%. In a separate study, Spiegel and her colleagues similarly limited the amount of sleep of 12 men for 2 nights and found that their levels of ghrelin, an appetite-stimulating hormone, had jumped by 28%. The amount of leptin, a hormone that tells the brain there's no need to eat, decreased by 18%. Not surprisingly, the sleep-deprived men reported an average 23% increase in their hunger levels. Taken together, these studies suggest reduced sleep could lead to increased weight gain, a hypothesis now supported by at least 50 other studies. Despite the remarkable effects of restricted sleep on immune and hormonal function, its greatest impact probably occurs in the brain. In a 2006 study, Robert Stickgold, director of the Center for Sleep and Cognition at Beth Israel Deaconess Medical, and Matthew P. Walker, now at the University of California, Berkeley, looked at how a single night of sleep deprivation affected emotional memories. 26 subjects, half of whom had been sleep deprived the night before, were shown positive, negative, and neutral words. For example, calm, grief, or willow, and asked to rate their emotionality. Then, after 2 nights of recovery sleep, they were given a surprise memory test. Compared with the subjects who'd slept normally, those who were sleep deprived before seeing the words for the first time showed a 40% deterioration in their ability to recognize them. But more striking was the relative impact of sleep deprivation on the 3 categories of words. Sleep-deprived subjects' recognition of positive and neutral words both deteriorated by 50%, yet their ability to recognize words with negative connotations deteriorated by only 20%. In contrast, the memory formed after normal sleep for positive and negative words differed little, with neutral words being less memorable than either positive or negative words. In short, the memory of negative words appeared to be at least twice as strong as positive or neutral words after study volunteers were forced to cut back on their sleep. So there's the frightening possibility that when you're sleep deprived, you form twice as many memories of negative events in your life than positive ones. Indeed, several studies over the past 25 years have concluded that poor sleep can even lead to major depression, among other psychiatric disorders. The evidence of a causal link with depression in particular has grown in recent years and comes largely from studies of sleep apnea, a disorder in which the flow of air into the lungs becomes interrupted during sleep. A 2012 study by the U.S. Centers for Disease Control and Prevention found that men and women diagnosed with sleep apnea are, respectively, 2.4 and 5.2 times more likely to have major depression. Of course, finding a correlation doesn't prove that one causes the other. But a recent analysis of 19 studies found that treating sleep apnea with a CPAP device, or continuous positive airway pressure device, which restores normal breathing and sleep, significantly reduces symptoms of depression. These suggestive findings deserve further investigation. Although researchers still don't know exactly how sleep affects mental health, they suspect the role sleep plays in helping our brains transform daily experiences into memories has a lot to do with it. Sleep participates in memory processing in everyone, no matter their emotional state. And sleep, after learning, leads to the selective stabilization, strengthening, integration, and analysis of new memories. In doing so, it controls what we remember and how we remember it. Around the turn of the 20th century, scientists considered memories to be fragile until they went through a process called consolidation, which transformed them into a stable form that could last a lifetime. But more recent research has shown that memories retain the ability to change even after the brain records and consolidates them. Indeed, reactivation of a memory can return it to an unstable state long after it was first formed. While in this form, it can be changed or lost altogether. This finding is both a curse and a blessing, for it means that originally accurate information can be corrupted, but inaccurate information can be corrected. Researchers have thus begun to talk about memory evolution instead of memory consolidation, especially when discussing sleep-dependent memory processing. The modern era of research into sleep and memory began over 20 years ago, when Avi Karni and his colleagues in Israel demonstrated that subjects trained on a visual discrimination task actually improved over a night of sleep, but only if they were allowed to enter REM sleep. Most dreams take place during REM sleep. Their experiment showed that sleep does more than just stabilize and preserve memories. It actually improves them. And further research suggests the brain strengthens different types of memories during different stages of sleep. But it seems not all memories undergo this sleep-dependent stabilization. In 2008, Jessica Payne, now at the University of Notre Dame, conducted a study in which she showed volunteers various scenes with aversive objects. such as a dead cat in the middle of a road. She found that after a night of sleep, the subjects could accurately recognize the image of the dead cat, but they'd forgotten the background street scene. Most striking, though, was that this selective forgetting didn't happen when she trained subjects in the morning and then tested them in the evening after a day spent awake. And it also didn't happen if the central image was non-aversive, say, just a cat crossing the road. So, sleep, but not wakefulness, caused the brains of the study participants to retain the highly emotional central images, as opposed to the neutral images and their background scenes. But it's not just emotional memories that are preferentially enhanced during sleep. It appears anything you think is important will be selectively retained. 2 studies in Europe have shown that telling subjects trained on a particular task whether or not they'll be tested on that information after they sleep affects what happens during that sleep. As you might expect, only the information subjects are told they'll be retested on shows improvement the next day. In contrast, when subjects are trained in the morning, informing them that they will or will not be tested that evening doesn't seem to make any difference. Sleep, then, and not wakefulness, selectively strengthens memories that the brain deems valuable. These findings support the argument of Daniel Schachter of Harvard University that humans evolved memory systems not to reminisce about the past, but so we can use prior experience to enhance our future performance. Sleep seems to care most about information that's likely to be of future relevance. When we talk about sleeping on a problem, we aren't just asking the sleeping brain to remember something. We want our brain to take the information already stored there and find the best solution to a problem. Lucky for us, it can. An example of this analytic ability is highlighted in a weather prediction experiment developed by Barbara J. Knowlton and her colleagues at the University of California, Los Angeles. Knowlton showed subjects 1 or more cards from a set of 4, circles, diamonds, squares, or triangles. Before the subjects began the task, the researchers assigned each card to a particular imaginary weather outcome, rainy or sunny, without sharing the information with the participants. Then, based on the cards shown, investigators asked those participants to predict whether the cards indicated the weather would be rainy or sunny. Over time, subjects got a sense of how the cards related to the weather. For example, the first trial might show the diamonds card, and the weather, the subjects are told, turns out to be sunny. Then, on the second trial, the circles and triangles cards are both displayed, and the weather turns out to be rainy. Even after just these 2 trials, subjects inevitably would begin to construct hypotheses about the relations, such as that diamonds meant sunshine. But then, on the 3rd trial, the diamonds card might appear again, only to be followed by rain. The trick here is that the cards are only probabilistically related to the weather. So, the diamonds card predicts sun 80% of the time, but for the other 20%, it's followed by rain. Other cards end up predicting sun just 20 to 60% of the time. In Knowlton's study, even after 200 trials, subjects still hadn't mastered the task, guessing the most likely outcome only about 75% of the time. Use of such tasks has allowed researchers to discriminate between different memory systems within the brain, those involved in remembering facts, the what system, and those involved in learning skills, the how system. As subjects train on the weather prediction task, they slowly shift from using the what system to the how system. What does all this have to do with sleep, you ask? Working in Robert Stickgold's lab, Ina Jonlagic asked what happens to this information with sleep, and obtained an amazing result. When volunteers who'd trained in the morning were retested the same evening, they also performed at around 75%, apparently fully retaining the information they'd learned that morning. But when other subjects were trained in the evening and tested after a night of sleep, they were 10% better at predicting the outcome than they had been the evening before. Somehow, the sleeping brain was actually able to improve participants' understanding of the relation between the cards and the subsequent weather. they'd gained a better model of how the world worked. The more researchers explore what happens while we sleep, the more they discover new benefits to a good night's rest. Given all the latest research on the many functions of sleep and the likelihood that yet more will be discovered, skimping on sleep is looking like a worse and worse strategy for dealing with the demands of daily life. Taken together, studies of the role of sleep in hormonal, immunological, and memory functions suggest that if you don't get enough, you could wind up sick, overweight, forgetful, and blue. Not to mention, very tired. This video was adapted from the article Sleep on It, which appeared in the Be a Better You issue of Scientific American Mind. The author, Robert Stickgold, is director of the Center for Sleep and Cognition at Beth Israel Deaconess Medical Center and an associate professor at Harvard Medical School.